The 767 is equipped with conventional steerable nose gear. The main landing gear are attached to the wings. The main landing gear is tilted when in the air. The landing gear controls are located on the forward panel. The landing gear lever has 3 positions: down, up, and off. The landing gear lever must be pulled out before it can be moved. The airplane is restricted to 270 knots or 0.82 Mach when the landing gear are down and during extension and retraction. Now use the landing gear lever to retract the landing gear. When the landing gear lever is moved up, the doors light illuminates to indicate the doors are open. The gear light illuminates to indicate the gear is in transit. The landing gear are up and locked. After retraction, move the landing gear lever to the off position to remove hydraulic pressure from the landing gear system. Extend the landing gear. The doors and gear lights illuminate to indicate the doors are open and the gear is in transit. The gear and doors lights extinguish and the gear down indicator lights illuminate after the gear are extended and locked and the gear doors have closed. Center hydraulic system pressure opens and closes the gear doors. Center hydraulic system pressure also retracts and extends the nose and main landing gear. Hydraulic pressure is removed from the landing gear system after the landing gear lever is moved to the off position. The main gear are then held in the retracted position by the locked door structure. The 767-300 is equipped with a tail skid. The tail skid helps to protect the fuselage from contact with the runway. The center hydraulic system provides power to extend and retract the tail skid. It extends and retracts with the landing gear. You control nose wheel steering with the rudder pedals and the nose wheel steering tiller. The rudder pedals turn the nose wheels up to 7 degrees. The tiller turns the nose wheels up to 65 degrees. The tiller position indicator shows the tiller displacement from the straight-ahead neutral position. The tiller overrides the rudder pedals if they are used at the same time. The center hydraulic system powers nose wheel steering. If the center hydraulic system loses pressure, a reserve brakes and steering system powers nose wheel steering. During ground operations, the landing gear lever is locked in the down position. After takeoff, you cannot raise the landing gear lever if the airplane's air-ground sensing system remains in the ground mode. The landing gear lever lock override switch unlocks the landing gear lever in any phase of flight. Push the landing gear lever lock override switch. You must push and hold the switch while you raise the landing gear lever. Retract the landing gear. Move the landing gear lever to off. The alternate gear extension system may be used to extend a gear if there is no hydraulic pressure in the center system. Or if the gear do not extend properly. The alternate gear extension system uses an electric motor to release all door and gear up locks. Gravity and air loads force the gear to the down and locked position. The gear doors remain open. Extend the landing gear. If the landing gear do not extend in the normal transit time, then one or more gear down lights do not illuminate. ICAS displays a gear disagree caution message. And the gear light remains illuminated to indicate the landing gear position disagrees with the landing gear lever position. Reset the master caution system. The gear doors advisory message and illuminated doors light indicate a landing gear door is not closed. Now raise the guard of the alternate gear extend switch. Select down on the alternate gear extend switch to extend the gear. The landing gear doors remain open after alternate extension if no center hydraulic pressure is available. The landing gear down lights illuminate to show all gear extended and locked. The tail skid light and ICAS advisory message tail skid display if the tail skid position disagrees with the landing gear lever position. The tail skid does not extend using the alternate gear extension system. When other landing gear components or systems fail, the messages are similar and the results are similar. Touch an ICAS message for further information. The 767 is equipped with a multiple disc brake on each main wheel. the nose wheels do not have brakes. The brake pedals provide independent control of the left and right brakes. The brake system includes the normal brakes, alternate brakes, reserve brakes, and a brake accumulator. An auto brake system is included, which operates when the normal brake system is functioning. Anti-skid protection is provided for all of the braking systems. The airplane is also equipped with a parking brake. The right hydraulic system provides pressure to the normal brakes. The auto brakes, the normal anti-skid, and the brake accumulator. The center hydraulic system provides pressure to the alternate brakes. Reserve brakes, and the alternate anti-skid. The alternate brakes are pressurized automatically if right hydraulic pressure for the normal brakes is low. Wheel brake temperature indication are displayed on the ICAS status display. The temperature of each brake is displayed on a scale from 0 to 9. The value and color of the number and box represent different temperature ranges. Lowest brake temperatures are in the 0 to 2 range, and the number and box are displayed in cyan. Normal brake temperatures are in the 3 to 4 range. The number is displayed in cyan and the box is white. High brake temperatures in the 5 to 9 range display both the number and the box in white. A brake temperature light illuminates when any brake temperature is 5 or above. The parking brake is controlled by the brake pedals. And the parking brake handle on the control stand. To set the parking brake, push and hold the brake pedals. Next, pull the parking brake handle until it latches in place. After the parking brake handle is set, release the brake pedals. The ICAS advisory message, "Parking brake," now appears. Hydraulic pressure now holds the brakes on until the parking brake handle is released. Hydraulic brake pressure is displayed on the brake accumulator pressure indicator. The indicator is located on the center panel. Before the right hydraulic system is pressurized, the indicator displays accumulator precharge pressure. The minimum acceptable precharge is 1000 psi. The right hydraulic system charges the brake accumulator. If right and center hydraulic system pressure is lost, accumulator pressure can be used to set the parking brake or apply wheel brakes. The auto brakes system provides automatic braking on landing when normal brake pressure is available. The auto brakes can also provide automatic braking during a rejected takeoff, or RTO. The auto brakes are armed for operation with the auto brakes selector on the center forward panel. The RTO mode is selected prior to takeoff. Select RTO for takeoff. The RTO mode is now armed. After takeoff, the auto brakes selector automatically moves to off. Reselect RTO for takeoff. During takeoff, if the airplane is on the ground and ground speed is above 85 knots, and both thrust levers are retarded to idle, the RTO auto brake mode will command maximum braking. The auto brake system maintains maximum braking until the airplane comes to a stop or until manual braking is applied. The auto brakes will also disengage if the selector switch is rotated to off, or the speed brake lever is moved from the full up position after the speed brakes have been deployed, or if either the anti-skid or auto brakes fault light comes on. Auto brakes are also used for landing. 5 levels of deceleration can be selected for landing. The higher the numbers, the greater the deceleration rate. Max Auto is the highest deceleration rate for landing. However, Max Auto is less than that of full manual braking. Rotate the auto brakes selector to 2. Auto brake application begins shortly after main gear touchdown when both thrust levers are retarded to idle. Deceleration is limited until the airplane pitch attitude is less than 1 degree. Then deceleration increases to the selected level. To maintain the selected deceleration rate, auto brake pressure is reduced, as other controls, such as thrust reversers and spoilers, contribute to total deceleration. The deceleration level can be changed during the landing roll by rotating the selector. As with the RTO mode, the auto brakes remain engaged until the airplane comes to a stop or manual braking is applied. Push the brake pedals to disarm the auto brakes. The auto brakes selector rotates to the disarm position. The ICAS advisory message Auto Brakes displays, and the auto brakes light illuminates. Auto brakes are disarmed. The auto brakes system also disarms if either thrust lever is advanced. The speed brake lever is moved from the full up position. The auto brake selector is rotated to disarm or off, or system faults occur. Anti-skid protection is provided in the normal and alternate brake hydraulic systems. Normal and accumulator braking use the normal brake metering and anti-skid valves. Alternate and reserve braking use the alternate brake metering and anti-skid valves. The normal anti-skid valves provide each main gear wheel with individual anti-skid protection. When a wheel speed sensor detects a skid, the associated anti-skid valve reduces brake pressure until the skidding stops. The alternate anti-skid valves provide anti-skid protection to laterally paired wheels. In addition to anti-skid protection, touchdown, hydroplaning, and locked wheel protection are provided. Touchdown protection ensures the rear wheel brakes do not have hydraulic pressure applied at touchdown. Hydroplane protection compares IRS ground speed to wheel speed and decreases aft wheel brake pressure when the ground speed is greater than wheel speed. Locked wheel protection compares the speed of each fore and aft wheel pair and releases hydraulic pressure from the slower wheel when the speed difference is greater than 25 knots. If the right hydraulic system pressure is low, the center hydraulic system automatically supplies pressure to the alternate brake system. If both the right and center hydraulic system pressures are low, the brake source light illuminates, indicating loss of hydraulic pressure to both the normal and alternate brakes. Pushing the reserve brakes and steering switch may restore hydraulic pressure to the alternate brakes. Push the reserve brakes and steering switch. The reserve brakes and steering control valves are repositioned to isolate the center hydraulic system to supply fluid exclusively to the alternate brakes and nose wheel steering. The reserve brakes and steering isolation light on the accessory panel illuminates, indicating the control valves have moved to their isolated positions. Also, the center number 1 electric hydraulic pump is automatically activated regardless of the pump switch position. The brake source light extinguishes. The center hydraulic system pressure is now dedicated to reserve brakes and steering. These ICAS advisory messages can be displayed for conditions or failures which affect the brake system. Select an ICAS message for further information.